My friends, in this video, we will be talking about predicting the products of hydrogenation reactions. We're not going to talk about the mechanism, that is how reactions happen. We're just going to talk about predicting the products. And hydrogenation reactions are one of the easiest reactions to predict the products for. Notice in hydrogenation, you see the word hydrogen, and that's because we're always adding H2 to a compound, to an alkene. And in line angle structure, it's really straightforward. So here we have an alkene being added to a hydrogen, and we'll talk about this guy in a second. What do we get? All we got to do is get rid of the double bond and redraw our structure. Boom. That would be the correct product. Now we're going to talk more about what this reaction is and do more practice problems. Basically what's happening is the hydrogens on either side of this H2 go and add to either side of that double bond. So one goes here and one goes here. And we get this structure now with extra hydrogens and the double bonds gone. Let's talk about that in a little more detail. First of all, what is a hydrogenation reaction? It's the addition of H2, as we've already seen. So here's H2, and here's H2 in my reaction, to an alkene. An alkene, remember, is just a carbon-carbon double bond containing molecule. So here's an alkene. And the presence of a metal catalyst. So you'll often see catalysts in your organic chemistry reactions, and they're listed above the arrow. They're not part of the reactants or the products. Instead, they just help the reaction along. In this case, you'll usually see platinum or maybe palladium or nickel. The good news is it doesn't matter what's written up there. You'll get the same products. Okay, so how do we predict those products? Well, here's two tips. For line angle structures, like we saw in the last slide, just remove the carbon-carbon double bond. Secretly, this is adding two hydrogens. For other structures, we have to remove the carbon-carbon double bond and explicitly show the hydrogen adding onto each side. Remember that our bond here is made of electrons. So what happens is those electrons go out and grab these hydrogens. And we eventually will get one hydrogen on one side of the double bond and one hydrogen on the other. Okay. First of all, let's just copy the molecule here. This is actually a good rule of thumb whenever we are predicting the products for a chemical reaction. Copying the main reactant will help us in that. So we're going to put our CH3, and then we see that that goes down to a carbon, and it goes across, double bonded to another carbon, and then down to one more carbon. We have a hydrogen going up and a hydrogen going down over here. So notice all I did first was just copied that. And that's always a really good first step. If you're just stuck in an organic chemistry reaction, it's going to look a fair bit like the initial reactant, the initial hydrogen and carbon containing molecule. And now all we do is we're going to take these hydrogens, I'll put them in green. We're going to add a hydrogen here, and we're going to add a hydrogen here, and get rid of this double bond. Let's make that a little neater. Get rid of this double bond. There we go. That's our product. All we did is we took our alkene to an alkane, right? So hydrogenation actually converts an alkene to an alkane. We just get rid of that carbon-carbon double bond and hydrogens add on either carbon on either side. That's it. So we get rid of a double bond. Bang. Okay, let's do 3 more practice problems relatively quickly. We're going to show the product of each of the hydrogenation reactions below. The line angle structures are your friends. They make this process way easier. So all we're going to do is copy the structure that we see. And we have a double bond there. And remember, for line angle, all we freaking got to do is get rid of the double bond. That's it. That's our whole product. Now remember, those hydrogens, just like in the other way to draw the structure, have added to either side of the double bond. But because line angle structures don't show hydrogens, all we have to do is remove the double bond, and the added hydrogens are assumed, and we're done. So easy. So frustrating to get that problem wrong on an exam when you see that the correct answer was just getting rid of the double bond. Okay, now another one in expanded form. Again, I'm just going to start out by copying the structure. I like to start with the carbons when I copy a structure because they're kind of the main part of that thing. Okay, and now what I need to do is I need to add the hydrogens. Again, we'll use those in green. So here's these extra 2 hydrogens going to either side of the double bond, and we get rid of the double bond that's connecting the 2 carbons. Bam, that's the product of that hydrogenation reaction. Okay, last one, also a line angle structure. And this time we have a cyclic structure, and sometimes people can be a little confused when they see a cyclic structure, but same basic process. What happens is the hydrogen adds to either side, and we just draw the structure, and we get rid of the double bond. So easy. So I do that. Now I had a double bond there. The hydrogenation gets rid of it, and that's the final product. So that's hydrogenation reactions, the adding of H2 to an alkene, and we get an alkane.